device used to measure the rate of water infiltration into soil.
As you can see, it's made up of one outer ring like this, and an inner ring like this, and you bash it into the soil 5 centimetres using this equipment.
Using the data we gathered from the previous methods, we can calculate the unknown in this equation, which is the infiltration rate.
The infiltration rate can be measured using this equation, where the V value is the volume of water added in time, the dV value is the diameter of the inner ring, all squared, and the time value is the change in time, which is the water added into the inner ring during the experiment.
We don't need to measure the diameter of this outer ring, as the outer ring is used purely to saturate the soil surrounding the inner ring.
So that the water can infiltrate directly beneath the inner ring, so that the column of water below can be recorded. We're now out onto the field, and as I mentioned previously, we drill the inner ring infiltrometer using the basher 5 centimetres deep.
Surrounding the inner ring, we then bash the outer ring into the ground like so.
Picked a better day for this. We remove debris from the surrounding area so water can infiltrate into the soil.
In order to saturate the soil surrounding the inner ring, we pour water in the space between the inner and outer rings, like so. So we pour the water over something such as the end of the hammer to make sure we don't disturb the soil. We've recorded the volume of the inner cylinder in the lab, and then using a 2-litre measuring jug, we will keep the volume of water at the maximum of the inner tube and keep topping up once it has gone down. And then in order to measure infiltration rate, we will record the change in volume of the jug.
2 litres.
2 minutes later, and as you can see, the water has already infiltrated through the soil. So using the 2-litre measuring jug, we will top up the inner cylinder and record the change in volume of water in the measuring jug. Water is infiltrated down the inner tube. And as you can see, we started with 2 litres of water in this measuring jug, and we have gone down to 1.3 litres of water less in the measuring jug.
We can now use the change in volume and plug it into our formula, which we showed you earlier. The second method for this experiment involves the inner tube being filled up to the top, which is 2 litres, and we record the change in time that it takes for the 2 litres of water in the inner tube to infiltrate to the halfway mark where we have the marker, and that is 1 litre. We can plug this into the equation and we can measure the infiltration rate. Time has passed and we can see how long it has taken for the water to go from the top of the infiltrometer to the marker halfway down.
The water we've used has come from this lake, and before doing so we filled out a risk assessment to make sure there were no hazards in the area. So there are a number of advantages to the double ring infiltrometer. The first of which is that by saturating the soil surrounding the inner ring, so putting water in the outer ring here, it improves the accuracy of the results. Other advantages to this method are its rapid installation, which allows us to obtain results much faster. It's also a very cheap piece of equipment and extremely easy to repeat, which means you can obtain multiple results quickly, allowing you to determine a mean quickly as well.
There are also some disadvantages to this method. For example, the water in the outer ring here can move laterally into the inner ring, and vice versa, the inner ring water can move outside, so there could be an overestimation or underestimation when measuring the infiltration rate. The second disadvantage to this experiment is that if the water used is colder than the soil temperature, then the dissolved air from the water will go out of the solution and increase the trapped air in the soil. This will increase the entrapped air content of the wetted soil, which will create a backing up effect and decreasing the infiltration rate. The third disadvantage from this experiment is the soil disturbance from the insertion of the ring, and this is from the bashing, and this can cause compaction or loosening of the soil depending on the soil type. There is also erosion of the surface when the water is poured in.
Around 1,300 millilitres.
Infiltration rate. Shit, it wasn't measured up to 2 minutes. My bad. Plenty of time.
The water